like clients and like the end users, you know. You might think that's a caricature, you might think, oh, well, I'm an engineer, that's the exception to the rule, but generally it's true. It's the payoff for being narrow and disciplined and drilling down into problems. It leaves you with these other things that in your own career and your own education you paid less attention to. But in the innovation process we only have maybe 3 groups of people we've got to think about: clients, designers and users, you know. You're a specialist kind of designer in the middle of it all. This is a way of representing, this comes from a designer called Charles Eames. So this is a management diagram really. It's a Venn diagram, you all know what a Venn diagram is. And it's saying there's clients, designers and users and they overlap each other. And you only really get a good business that's valuable and sensible and profitable in the overlap, okay? And you can be working away in one of these half overlaps, but it's not going to come to fruition. So you can have a good client who's funding you, you can have a good piece of technology that you're working on, you're a good designer or you've got a good design team, but people don't want it. You discover later on. The alarming thing for engineers is that they discover in their careers, and this is increasingly true, that a lot of problems are not really solved in a functional, systematic way. They're social or they're even irrational. Okay? Human beings are not very rational. If you might work in a business that's doing some pretty sophisticated high-tech stuff, and you might discover the market is very willful or strange, or you just cannot predict what's going to happen. Okay. Now, this is a little illustration of this. Last year, Rainer's team worked with a company called Best Bars, which is a tow bar company in Auckland, and we were struggling to make our undergraduates design something that wasn't just like an engineering solution, but was also like a social solution, or was like a solution that encompassed marketing. And we didn't really get very far with that, I don't think. They did solve some technical problems. I was driving around in America and I saw this product in front of me, and this is what it was. It's a fish. This is a tow bar cover, which you plug into the electrics, and when you hit the brake, the fish, his eye lights up and his tail wags. It's a piece of nonsense, you know, really, but it's $40 and people love it. Okay? And we could have never predicted that. And like a few months later, I thought, wow, this is really, you know, something quite extraordinary. Someone is making quite a good business out of that. You know. This is exported to the UK. It's made in America. So you can never quite outthink the strangeness and weirdness of human behaviour. So this is an alarming conclusion to come to if you're a rational, sensible, conscientious engineer. So let's move quickly to some of the big problems. That's an overview of an outsider about engineering. What are the problems that you're dealing with? Well, you know, you're close to them, you think about them, you have a kind of social awareness. We'll just rattle through them. Cities, pollution, biodiversity, forestry, water, energy, all the areas that you're thinking about in your own collective engineering without borders will be impinging on these kind of things. There are huge water problems around the world. There are huge energy problems. The strangeness of energy is that there's a lot of ambient, low-grade energy around, but we don't know how to use it. We do stuff like solar collectors that don't quite work. We have photovoltaic cells that are pretty good, but they're still fairly expensive to produce. You know. So we're now thinking about these in the developing world, or designing for the other 90%. I mean, I've said some things which are congratulatory about the automobile as an individual piece of technology, but as a system of transport, it's nuts. It's just incredibly bad. There's a complete mismatch between what this instrument can do. A car can travel comfortably at about 50 miles an hour, that's its optimum. You can travel faster than that. If you go faster than that, there's an aerodynamic handicap. But the average speed of traffic in most cities is about 11 or 12 miles an hour. So from an engineering point of view, this thing is massively over-designed. And then you might say, oh, well, it's very good at intercity transport. Well, it's not terribly, because it's actually quite dangerous to drive on the kind of roads that it's driving on. And people try and drive at a speed that is excessive in relation to the piece of equipment. So almost any of these points you touch upon, there's really serious deficiencies. One of the areas that interests me is to do with sustainability, which is about using resources more carefully. Here's a couple of examples. I call this creative scavenging. Just use what we've got, put it together in a new way. This is a building I designed for myself, but I made a rule that I wasn't going to throw anything away from the existing building, which turned out to be something of a handicap, or I scavenged for things like a cast iron staircase that I found. The wood, the black wood you can see is the original truss, and then you've had to beef it up. Was it successful? Well, partially. If you set yourself a target like that, you say, well, I got all these glass bricks that I'm just going to reuse. I got all these bricks off the floor that I'm going to reuse. You find that you can achieve what you want, but it doesn't necessarily come out as a cost saving. Okay. Here's another more extreme version of the same idea. This is a great architect called Samuel Mockbee, who, with his own students, is designing buildings that are sourced from the rubbish dump. And this is a community centre that looks a bit like a cathedral, but these are all windscreens from cars. Okay, it's absolutely brilliant. It looks great. It functions perfectly well, and he's reusing the stuff off the dump. So you can look Samuel Mockbee up, or you can Google him and find a lot of work that's in a poor part of America, Virginia and Tennessee. And here he is making walls with some of his students out of car tyres. Car tyres are a huge problem environmentally. They're great on the car, but then they're dumped, and they're quite difficult to destroy because they've got steel cores. People burn them, and they're enormously polluting. But here Samuel Mockbee is saying, well, with a fair amount of labour, you can make quite an interesting bulk retaining wall. Okay, and I got a figure there. They could fill tyres with concrete at about a level of 30 a day, which isn't bad. You can knock off a fairly big structure. So that's the kind of thinking that I'm sure is part of what you're doing. If you look around, you find that there are pieces of technology that have been discovered and are underused. About 3 years ago, I came across this company that it's called Aqualogic, and it had a ceramic filter. Are any of you doing stuff on water using high-grade ceramic filters? You can use ceramic filters to get out all contaminants, including microbes. The only thing it doesn't deal with very well is salt water, but any inland water it'll probably do pretty well. Now, at the point that this guy was demonstrating this project to me, within a matter of a few days, there was the tsunami in Asia. He found it really difficult to get support. But this is the kind of environment where you really, really need something like that. Immediately after a disaster, there are major problems about water supply. And that's what it looks like. So if some of you are thinking about water as a problem in your projects, or are interested in developing this, have a look at this. Find out